Hello geeks, welcome back to your favorite YouTube channel My Project Ideas. I am Simran and today we are delving into the fascinating world of DSA. We are here with another interesting topic that is modular arithmetic. So guys, gear up and let's see what this topic has in hold for us. Here we go. What is modular arithmetic, guys? Modular arithmetic basically deals with the remainder when one number is divided by another. Simple. It's often referred to as clock arithmetic. So what are the basic operations of modular arithmetic? Addition, subtraction, multiplication and division. In case of addition operation, first you add the terms, then you modular divide it. For example, 7 plus 5 mod 3 gives 12 mod 3, that is 0. 7 minus 5 mod 3 gives 2 mod 3, that is 2. 7 into 5 mod 3 gives 35 mod 3, that is 2. So you're just getting the remainders. Okay? Simple? Then guys, this modular arithmetic topic is not just a mere usage topic. It's not just for theory purpose. It's used for practical uses as well. Now you get to know that DSA concepts are not just for making your coding strong, but improving your visualization to the practicality of the topics as well. So where are these modular arithmetic topics used? Cryptography for encryption and decryption in cybersec. Computer science, hash functions. We will learn about hashing in the upcoming video lectures. Then number theory. So in case of number theory also, this modular arithmetic is quite used. So modular arithmetic simplifies calculations in systems where there are finite bounds and has various practical applications in different fields. Got it? Now, what are certain theorems that we use while we are reading about modular arithmetic? There are certain quotient remainder theorems. Certain theorems are quite simple. We read it in school. So what is quotient remainder theorem? You know that dividend equal to divisor into quotient plus remainder. That is the same thing. That is called the quotient remainder theorem. What is modular addition? A plus B mod M can be written as A mod M plus B mod M. Modular multiplication can be written as A into B mod M is equal to A mod M into B mod M. Modular division, it's very different from the modular addition, subtraction and multiplication. It also does not exist always. A by B mod M is not equal to A mod M by B mod M. It's not equal. How do you calculate it? A by B mod M can be calculated as A into inverse of B if that exists and then mod M. Okay? Modular inverse. The modular inverse of a mod M exists only if A and M are relatively prime. What are relatively prime numbers? If the greatest common divisor of both the numbers are 1. Okay? So if you want to find out the inverse of an under modulo M, suppose if there is an example A into B mod M is equal to 1, then B is the modular inverse of A. This is a fact. This is what you call, this is an thing which you should remember. It's a formula. Suppose, again, let's repeat it. If A into B mod M is equal to 1, then B is the modular inverse of A. Simple. For example, if A is equal to 5, M is equal to 7, if 5 into 3 mod 7 is equal to 1, that is 15 mod 7, where you get the remainder as 1. So 3 is the modular inverse of 5 under 7. Okay. So 7 is a, what do you call? It's a factor. Under 7 means 7. If you divide it modularly by 7 only, you get the answer 1. Then modular exponential. So like modular exponential is power of something. Suppose A modular exponential B is A to the power B mod M. So there are two approaches, again, because you know how to find out the power. We discussed in previous lectures. So you can do it by two ways, that is recursion and iteration. So here you can use anything. Okay. Now, so here you have a recursive function which we discussed in the previous lectures, and you know that the time complexity is big of log n if you use recursion. And you can see here like x to the power n is equal to 1 if n is equal to 0. Simple, because x to the power 0 is 1. If n is even, you can do it x to the power n by 2 into x to the power n by 2. And if n is odd, you can do it as x to the power n minus 1 into x. Simple. In this box, you can see we have written down a simple algorithm which indicates this. Okay? But we are gonna code it, guys. Don't worry. So let's code it now. So the time complexity will be big of log n, because while we already saw if the number is even, see, if it is n is even, then we are gonna make it half. It's always n is always halved. So according to a theorem called Forman's theorem, x to the power m minus 1 mod m is equal to 1, where m is prime and x and m are co-prime. Simple, no need to remember all this stuff. Just need to know how to code, and you just need to know the time complexity. That's it. Now our task is to write a code for the same. Now guys, I already said you about the algo here. This is the algorithm that we are gonna use. Same algorithm, guys. So if you understood it, I recommend you to pause this video for a minute and just write the code by yourself. Then come back and check your code with mine. So let's move to our text editor. Here we are. Created a file. Let's save it and let's start writing the code. First, create a function. Mod par. The parameters. Okay. Next, we are gonna check if n is equal to 0. Then what do we are returning? Simple thing. 1 mod m. The same algo, guys. Next. Next, what we are gonna do? U is equal to, let's make it a recursion, mod par, and the parameters will be, you know that it will be like the recursion, you need to pass the parameters, because it's gonna stored in a recursive call stack with the same function which we are using. I've already said you about recursion. So what happens in recursion is, the function, without using a loop, we are gonna work without using the loop, you are gonna work as a loop works like. Simple thing. Then u is equal to u. Then let's check for even. If n mod 2 double equal to 1, then u is equal to u into x mod n. Then we are gonna return u. Simple thing. Return u. Done. Then guys, our code is already done. Now what we need to do is, we need to write the main function here, the driver function. If name is equal to, here is main, okay, and we are going to print what? The mod hour, and the parameters are 5, 2 and 7. Let's save it, let's run it, and you get the output as. So I hope you understood this code, you understood the topic quite well. For today, let's wrap up this session. And until then, keep coding, keep learning, keep rocking. I'll take you leave now, guys. Bye bye and have a great day ahead.